It's directly related to the fact that we added that word difference into here. It is not required, but it is definitely helpful. Now you're going to hear me stress this a bit over the next 4 class periods because of the dangerous nature of it. Right? Today we're going to be talking about true average difference. Tomorrow we're going to still talk about matched pairs, so true average difference. On Friday we're going to talk about 2 sample means. And when we switch to 2 sample means, it's not going to say true average difference, it's going to say true difference in average. Right? True average difference. Right? And on Friday, true difference in average. What's different? Just other than the order of the words, what's the meaningful difference between those?
The true difference of averages can be the difference between the averages that you find, while the true average difference can be the difference between individual pairs of information.
Right on the, I think you were stumbled across yourself a little bit. You're right on track. Yeah, true difference in average, exactly as he said. It'll be the differences between the averages of 2 data sets. Right? Here, average difference is the average of the differences between data. So we're actually going to be pairing the data, hence the name matched pairs. And so we're going to put 2 data sets, mash them into one, and then find the average of that difference. And big difference, it seems small difference in words, but if you mix it up along problems, it starts turning into parallel solutions. As we go forward, and again, I'll say this a few times over the couple of days, if you mix these intervals up between today's and Fridays, and the worst thing to do is to actually do a matched pairs when you shouldn't. Because if you do a matched pairs in a 2 sample situation, it's a 0. It's nearly impossible to get any points out of or recover from. If you do a 2 sample in a matched pair situation, you can sometimes get at least half because there's enough overlap and there's still enough statistical reasoning behind doing a 2 sample as opposed to a matched pairs. Okay, but one of the major things you'll see in the conditions is one of the reasons why it doesn't work the other way around. Look at those quickly before you start writing them down. Make sure what's different. What's new, what's different. Someone say one thing, subtraction order. Right? That can be done in step 1. You can include that right in step 1, either in how you word it or as a separate component. You'll see me do that both ways along the way. Right? What else is different? Yeah, related data as opposed to what? Independent, yeah. Told you, when we get to the point where independent doesn't make any sense, it'll make sense that it's not there. Right? If I'm taking data sets and I want to directly relate the data, can that data be independent? No. The whole idea is I'm taking data and they're doing a direct matchup. So we're looking specifically for the data that can directly relate to itself. Your right hand versus your left hand. And our first example is a mothers and daughter pairs. Your pre-test to your post-test. Right. Random is still there. Normality check is a little simpler than the t-interval. It's because you're always going to have data. Match pairs questions always provide data, and when they don't, they actually will give you the box plot and not a sample size. You'll actually look at them and say, okay, there's the box plot of this differences. This is why I can say approximate and normal, or no deviations from normal, variance and non-normality, whichever words you use. Not approximate. Don't use that. Now, the significance of subtraction order comes into the fact that we're doing differences. We're going to add and subtract data. So, if if I subtract data, A data set versus B data set, and in the end, my result is greater than 0, hence positive, that tells me that whatever A was is greater than what B was. If I get my interval, and my interval comes out less than 0, or negative, and I did A minus B, that means that A was smaller than B. And that'll play an important role as we go through the process of how does this information do any good for us. And so having that subtraction order is a necessity. If you say you're going to do A minus B, and your interval comes out all positive, but then it should be all negative, basically you have to match up your work. So that's going to tie into the normality check again. We're always provided data, so we're always going to do a box plot. And the box plot has to be of the difference data. And so when you're doing these, you're going to have data set 1, data set 2, and then you're going to create a difference. The one we care about is the difference. That's the whole purpose of the interval. That's the whole purpose of what needs to be normal. If you think about situations, it makes sense that we'd want the difference and not the original data. Something like post-test and pre-test scores, or even right hand versus left hand. And going into the situation, you have different people are better at skills in general. And so if you're going to do a pre-test for something, some people have prior knowledge. Some people are going to score better already. You're probably going to have a skewed distribution on a pre-test. Now the post-test will probably be less skewed, but still most likely because of that initial prior knowledge skewed. When I mash the data together, it normalizes because the idea is we're looking at the differences. So you're going to have some high differences, some low differences and stuff in there. And so it takes away that whole people know something, because someone who did really well in the pre-test is probably not going to do as significantly better on the post-test as someone else. You're going to see similar change. So, all right, and then degrees of freedom here says pairs minus 1. Basically the idea again is we're looking at the difference data. If I have 10 of these and 10 of these, that's 20 pieces of data, but I'm going to turn it into just 10 pieces of data by doing the differences. So I've got to do pairs minus 1. Now, the interval itself will look slightly different just because it's common notation to use D bar instead of X bar. Okay, so it's the same formula, it's the same concept, it's the same purpose. We just use a different letter as a reminder of we're doing the difference. So it's just D bar meaning average difference. Now, because this is data, the written formula itself is not required because this is coming from data as long as the interval is named. And so if I forget to do match pairs t-interval in the conditions, but I write it out the formula properly, those kind of counteract each other.
On the last test, because we have just covered the formula.
The only time you weren't required on the previous quiz was the data set. You did not have to, and I did mention it. Mainly because I want you to know that the one sample formula is because of the sample size. Right? If you write both the formula, if you write that formula out enough, if you get stuck on a sample size question, you can hopefully do the algebra to solve for sample size. It's training.
Got it. Plug the formula. So if I just look at it and then plug it in.
If you write out the formula without plugging it in, as long as all variables are identified somewhere in the page, you're fine. And so as long like if you write out the formula but don't tell me what p hat ever is, that's a problem. You know, if I don't know what the mean is somewhere else in the paper, that's a problem. So a filled-in formula is always better when everything's there. Because the nice thing is a filled-in formula then implies those variables if you use them elsewhere. That's why we make you write out the z formula. If you write z equals, that identifies the mean and standard deviation of a normal distribution. If you don't write z equals, it's an empty formula. Okay. So one thing I suggest is, because of this, I would actually just add right up here, right after doing degrees of freedom, show t star. Right? Just because you're going to get into the habit of forgetting it because you're not writing the formulas off. Okay, so degrees of freedom is where you get t star from. If you got one, you might as well do the other. Alright, sentence, again, the main difference is going to be that true average difference. And it has to be there in those words. It's how we've been stressing true. Right? True average difference, those three words have to be there. I'm going to Chromebook under their desk. Yeah. True proportion and true average, yeah. Yeah, that word true is always there, or population, if you can exchange it for it. True shorter. Okay. Questions? Now, like a lot of these problems, it's the setup that takes the longest. Really, the execution, the calculations, they don't take as much. Now, these ones, match pairs and the two samples, are the most meaningful ones as we do things, because you can get a lot more information directly from the interval. It gives you a lot more meaning. A one sample interval just gives you a range of a parameter, and that parameter could be helpful, may be helpful. And when you know about a difference between something and two, the comparatives are a lot more powerful. All right, so we're going to go through the same steps, plus going to show you some calculator pieces along the way to help yourself out. We're looking at data. Right? First thing you want to ask yourself, you want to start looking at this over the next couple of days so you get the idea of when it's paired, when it's not. And almost everything we're going to do in the next couple of days is going to be paired. I'm going to show you a couple examples that aren't in the worksheet tomorrow, but we're not going to work them out until Friday. Okay? So you want to make sure that I can tell that there's a direct relationship between the data. That's why the independence condition's gone. We're looking for that related data. As soon as you can see that connection, then you know you're doing a matched pairs test and you can keep going forward that direction. So essentially the way they have this, we're pairing a mother with her daughter. Right? So making that direct connection. It's not, here's a bunch of mothers, here's a bunch of daughters. I don't know who belongs to who. Okay? So with that said, then we know we're looking for true average difference. Now, here's where I like to do my subtraction order. I like to put it in right in the definition of parameter. The order that you subtract is arbitrary. Some people do it out of ease of setup. Mothers on top, daughters on bottom. Some people do it out of context. Okay? Sometimes, in certain situations, a lot of people like positive answers versus negative answers. If you're looking for positive result answers, then you might have to subtract in a certain way. A post-test score is likely to be higher than a pre-test score, but the pre-test score is probably going to be listed first. So So if you want a positive result, you don't want to talk about a negative result. If I do get negative results and show that to the principal, even though the results are actually meaningfully positive, when you show someone who doesn't know statistics something, then you get yourself into trouble. So sometimes you want to subtract in a certain way. All right. Name of this is matched pairs t-interval. Right? There is no matched pairs t-interval in your calculator. This is going to be the same t-interval that we used before, but we want to call it the matched pairs t-interval or paired t-interval. These mothers and daughters were selected at random, so we can say that. Now, be careful here. A couple people along the way used SRS, but does it say SRS or does it just say randomly selected? Okay. You can't imply things that aren't true. We learned about a whole bunch of different random data collection methods. SRS is a specific type. Okay. We already talked about the fact that yes, this is related data. I typically do the degrees of freedom in T-star before the normality because the normality is the one that takes the longest. The degrees of freedom, we have 7 pairs, so that'll be 6. This one says a 98% interval. Use your table. 1.34. Now, the normality check is the one that's going to take the most work, and it really is up to you how you do it. There's a couple ways that you can do things. Method number 1, you do the subtraction yourself. So we said mother minus daughter. I go through and I subtract each of these numbers by myself. And I come up with that difference. So I now have my difference data. I can put that in my calculator. Small data set, whole numbers like this, why not? Easy to do. Okay? I would hope most of you can do 62 minus 63 and so on. Okay? Big data set, decimal numbers. And it doesn't matter how smart you are, you're going to subtract wrong all the time. Actually, probably the more intelligent you are, the worse you are with simple addition and subtraction. Right? So it's actually a common thing to happen. You lose lower math skills the higher your math skills become. Because you usually don't do them as much. If that's the case, there is a way to do it in the calculator. So, calculator method, I'm going to put the mother data in list 2 and the daughter data in list 3. Yes, list 2 and 3, not list 1 and 2. Okay? There's a specific reason for that. When I tell you to reset your calculator every time you take a quiz, your calculator resets the default. So anytime you go back in and go to second y equals and do the plot, your calculator is going to be looking at plot from list 1 by default. And so by putting the mother and daughter data in list 2 and 3 and the difference data in list 1, I guarantee that I'm going to select the correct plot, because if you don't pay attention, your calculator will give you a plot and you might not realize it's the right or wrong one. Right, so it is a little bit of a twist, but it's a twist with a purpose. Right? So then you're going to do list 1. I said mother minus daughter, so L2 minus 3. You said daughter minus mother, you would do L3 minus L2. So your subtraction order doesn't matter. And so this is back in where you entered the data, not where you're running the test or anything yet. All right. Now, by default, your data, the important data is in list 1. Your calculator is defaulted to list 1. Go turn on stat plot 1 with list 1 and a scatter plot with outliers, and you can check your normality. If you're not careful, don't pay attention to where your difference data is, you'll get a plot because you have data that works, and you might not realize that it's the wrong plot. And if you draw the wrong plot, rubrics will have specifically the plots of the mothers, the plots of the daughters, and the difference plot, just to make sure that people are putting the correct plot on the paper. If you have the mother's plot and say that it's bad or that it's good, it doesn't matter. If you have the mother's plot, you're gonna lose 2 points because your normality is done from the wrong plot. And so you lose 2 points off of that. On an AP question, you lose your conditions. It's enough of a mistake that you lose your condition component. So you're doing best 3 out of 4. Okay? Now, once you have all that done, really that's the trickiest part. It's, everything else is the same as our T interval. So you can go back to stat, test, T interval, and get your interval values. And again, because this is coming from data, I'm not stressing the formula. If you want to write it out once you do the T interval, you're welcome to. Just make sure you fill it in correctly. If it's on the paper, it's got to be correct. And you fill in a formula, switch the mean and standard deviation or something, that counts against you. So don't do extra stuff unless you know you're doing it right. Right, and of course our sentence here. Our main thing is the heights. We've already talked about mother and daughter in the definition of parameters, so I can shortcut my sentence a little bit by just making sure I talk about heights. Other little things. The differences that are written on the paper, not required, but they are a safeguard. Right? You either copy them off your calculator or do them yourself. And oops, I added instead of subtracted. That you better catch, because if you add these data together, it's going to be a data point that makes absolutely no sense. Oops, I subtracted one of them in the wrong order, so I have a positive instead of a negative. That one you might not catch. And in an AP exam, okay, I'm not supposed to guess that you did that when I grade it. But if you have it on the paper, the difference is I'm allowed to look at evidence. So having the differences written down, oh, they subtracted this one data point in the wrong order. That's why their interval looks different. Now you can actually potentially even get full credit. Right, so it's one of those, I don't require this, but it can help you. Yeah.
Nowhere in the problem doesn't say inches, so are we allowed to write that? Are we allowed to give like in 5 units? Because nowhere in the problem does it say the height is in inches.
Oh, yeah. You can, yeah. You can say units if you're concerned. But I thought I actually had fixed that on this one. Guess I didn't. Yeah.
We're not allowed to do that though, like imply.
You can imply some reasonable units, like here because it's heights and the way they are, inches is a reasonable unit. But if you're concerned, the word units is totally acceptable. All right. Anything else with the basic setup before we look at the follow-up questions? All right. So first follow-up question on your paper. Second one is something I added. I want to talk about. Take a look at that. Look at your interval. Make a decision for yourself. Provide some evidence. Second one, just go in your calculator, change it to 90, write out the new interval. See if you want to say anything different or the same as what you said would be. Think about B. Anyone tell me what they said and why? quick show of hands. How many said, yes, we can tell that there's a difference in the heights? How many said, no, we can't tell there's a difference in the heights?
B?
Or B, yeah. Okay, so someone who said yes, why do you think yes? And who is taller than? So if you said yes, you have to tell me who's taller. Or someone who said no, tell me why you said no. Either way.
I'm a little bit confused, but maybe no, because zero is also part of the interval where there will be a difference between mother and daughter is. But when you change your interval to 90%, all of the differences are either negative, well, in this case, negative, meaning the daughters will become mother.
So in B, the original interval, the answer is no, for exactly what she said. Zero's in that interval. Right? Remember, your interval creates a possible range of value. And the easiest thing to talk about is zero. Person in first period they explained it said that the interval both is positive and negative, meaning you can get either a positive difference or a negative difference, therefore cannot tell. That's a longer explanation, but a correct explanation. The simplest explanation, and the one you want to think about most often, is where's zero? Because zero in this case means no difference. If zero's there, it's possible. And we created a 98% interval with a rather small margin of error. And Alex was exactly correct in C. Switch up that interval becomes all negative. Now, you should have anticipated the shrinking of the interval. Crossing into completely negative, maybe not, but shrinkage, yes. Right? And then this is where that subtraction order is going to come into play. Now that I know that the entire interval is negative, think about how you subtract it and what I did with my A's and B's. Substitute in mother and daughter. Right? Mother minus daughter is less than zero. That means that mother is shorter than daughter. You can use that subtraction to get very simple and clear evidence. One of the things that always happens on AP exams is students have this tendency to be given a lot of space and want to fill it. Right? Those answers that are there on the paper, that's full credit. Right? Short, sweet, to the point. You don't have to fill the page if you can answer it. The danger of writing too much is that you end up talking yourself out of something. Because if you waffle on an answer, then it becomes maybe, and maybes are not good. Alright, questions? Flip this over. There's two more examples on the back. I'd like to try to get through the top examples before we go. So start working on that one, plugging it in. If you need help with any of the calculator steps or parts, let me know.